EVs are the hot topic of the autonomous sector for quite some time now, and they are thought to be the next step of the automotive industry with the popularity they are getting. But there are also some dangerous EVs on the road, and in this video, we will be taking a look at some of those. The auto industry has been experiencing a dramatic shift as car makers look to increase the number of autonomous cars and electric vehicles on the road. EV sales are rising by leaps and bounds. Nearly 1.4 million EVs were registered in Europe during 2020, 137% more than in 2019. But this technology, like any other, has some bad side on its tab, like some fire incidents of Tesla that have been reported. Risk factors of EVs. For any electric cars, just like combustion engine vehicles which are to be sold, manufacturers have to comply with specific design regulations, and the majority of those features should ensure that their vehicle is safe enough for drivers. But even after that, there remain some risk factors. Combustible battery? EVs don't use those combustion engines, instead they use an electric battery. I know, you already know that. An electric vehicle gives very much the idea. EVs use lithium-ion batteries now, so this means there's no chance of catching on fire as there's no gasoline to ignite the fire, right? But lithium-ion batteries are flammable too. Most lithium-ion battery fires and explosions come down to a problem of short-circuiting. A separator keeps the two electrodes apart in the battery, but if something crushes or punctures a battery, they can touch. That would cause them to react, producing a rush of electrons. This is called a short circuit. But, lithium-ion batteries have a much lower risk of fire explosions than those combustion engines. To give you a perspective, lithium-ion batteries have a failure rate that is less than 1 in a million. As Elon Musk tweeted, Tesla, like most electric cars, is over 500% less likely to catch fire than combustion engine cars. Temperature range. Cold weather can substantially drop your EV's range. A lithium-ion battery has a much narrower range of operation, about 15 to 45 degrees, while modern standard vehicles are designed to operate in temperatures from minus 30 degrees Celsius to heat beyond 50 degrees Celsius. The Idaho National Labs found that an EV can lose 25% of its rated range at freezing temperatures. That study also found that fast charging was 35% less efficient at freezing temps compared to its efficiency at 77 degrees Celsius. Like humans, batteries also like to be comfortable and function best at moderate temperatures. Thermal runaway. Remember, we said earlier lithium-ion batteries can face short circuits. Well, this is one of the major aftermaths of that. Increasing the range of an EV can be done in multiple ways, from having larger battery packs with more modules and cells to putting in higher energy density cells with higher capacity. However, all systems are susceptible to thermal runaway. Each cell in a lithium-ion battery contains a flammable liquid electrolyte. If the cell short circuits, the electrolyte can combust, and the pressure within the cell will rapidly increase until the cell vents the flammable electrolyte, a process known as thermal runaway. When thermal runaway happens, it can produce smoke, fire, and even explosions. The electrolytes. Flammability of the electrolyte is a significant unresolved safety issue for lithium-ion batteries. The electrolyte in lithium-ion batteries, which is full of flammable materials with harmful chemicals, can catch fire under any circumstances, which can initiate every problem we just stated earlier. Silent EVs pose a threat? One of the benefits of EVs is that they are much quieter. But stop, look, and listen has long been the advice for children who want to cross the road. So what if the car is too quiet to hear? The big issue that has come up recently is that electric cars are so quiet that people out walking their dog or blind people who rely on noise to help them know where cars are running might not notice these silent running vehicles. Research conducted by charity Guide Dogs found that quiet hybrid and electric vehicles are 40% more likely to collide with pedestrians than cars with a regular combustion engine. Causes of an EV fire. Fundamentally, electric vehicles are extremely safe, but the main danger occurs when the lithium-ion battery is damaged, which might happen if it is exposed to extreme heat or something penetrates the battery cell wall. According to Professor Paul Christensen, an expert in the field of EV fires, lithium-ion batteries can store a huge amount of energy in a very small space, but naturally, that energy will try and get out. He adds, if the battery is exposed to excessive heat, or there is a penetration in the battery case, then you get an internal short circuit. Then he says that this short circuit will initiate a process called thermal runaway, as we explained earlier. It can lead to ignition, or in some cases even explosion, he ends. Safety measures. Combustion issue. Even if there's a little chance the manufacturers are working on making that percentage almost zero, to prevent external damage or short circuit, electric vehicle batteries are usually surrounded by a protective cooling shroud filled with coolant liquid. Besides, despite external cooling, all electric vehicles are installed in an array rather than one large, huge lithium-ion battery pack to prevent damage from malfunction. Temperature issue. Modern cars are designed to take that into account with battery thermal management systems. An EV's onboard thermal management system is designed to draw energy to warm or cool the vehicle's battery as needed, to ensure it operates in that ideal range. Therefore, the car is working to heat and cool both the occupants and the batteries in cold or hot conditions. To protect the battery, the most expensive component of an EV, the onboard computer may limit how it's used in extremely low temperatures. Not letting the battery get too low by making sure always having a 20% charge or so is also a good option to tackle this issue. Thermal runaway issue. What is important to prevent this is the choice of good thermal management material. These materials are purposed to stop the heat propagation using thermal insulation, or to drive the heat outside through a cooling system. To meet these goals, several material technologies are available on the market. The major ones are silicones and polyurethanes. Electrolyte issue. Manufacturers are questioning the problem by dividing the battery into small cells with separating firewalls. It can be at least delayed from spreading to neighboring parts. Some engineers are making less risky electrolytes, less flammable, and produce fewer harmful chemicals. Silent issue. The National Highway Traffic Safety Administration, NHTSA, has taken action to require hybrid and electric vehicles to emit a standard noise to warn pedestrians of a vehicle's approach. The NHTSA requires all electric cars to be outfitted with an artificial sound machine when traveling at slower speeds. Many automakers are taking this requirement one step further and creating customized sound to differentiate their cars from the competition. Most dangerous EVs. Tesla Model X. The Tesla Model X was the first car to receive a perfect safety rating from the NHTSA. This SUV has a higher center of gravity than the average sedan. This increases the likelihood of a vehicle tipping or rolling over. The heavy battery pack on the floor of the car is responsible for reducing its probability of rolling over. Tesla Model Y. This car joins those ranks of Tesla lineup with a midsize SUV scoring 5 stars in every category that the group tests for crash safety. To accommodate its higher mass and larger cabin space as an SUV, Model Y's body structure is fortified and strengthened even further than Model 3 in pursuit of its 5-star safety rating. NHTSA's assessment determined that Model Y has a rollover risk of 7.9%, the lowest of any SUV recorded to date by the organization. Tesla Model 3. Now this is the most hyped one in the EV sector, and this EV is one of the major reasons Tesla is reaching such accomplishments. This model received top marks from safety organizations across Europe, Australia, and the USA. A 5-star crash test safety rating from Consumer Information Agency Euro NCAP, and a 2019 Top Safety Pick Plus from the Insurance Institute of Highway Safety. If you like this video, give it a thumbs up to show your support. And for more videos like this, hit that subscribe button.